Hi, it's Dan Kelly here. This is an update to the R package called Mooring. I've made some changes in the past few days. And this is kind of a low-level thing, but it's because I'm using a different object orientation scheme. And it allowed me to kind of clarify my thinking a little bit. So the website for this remains that thing you can see at the top, github.com. I won't read it out because you can pause the video if you want. If you click on that place there, you get to kind of a web page for this. There's a README file with a little example with some code. At this, I can tell you the main difference from the user point of view. It used to be that, okay, so here in this line right here, I'm making a mooring. And it used to be that you had to give the length of the wire, or it's a parameter is called depth when you're making the anchor. And now you don't do that. You give all the constituents, I call them elements now. You give all the elements, and the last argument has to be water depth with camel case, as you can see. So that's the new way you do it. Other than that, everything still works the same as before. And we still have the same articles. Here's a practical example of a real mooring. It was a DFO, a BIO DFO mooring, which is in like about 1,500 meters of water. And so I just went through this thing. So this is on Ondra, RCM11, etc. And so that's what this is. So it's just creating it. So I made an abbreviation for that. Okay, so you can go through this, and so I won't belabor you with the details of it. And again, these things are still recovered. So this exact example, oh, I should say that I've changed this example. I've decreased the current. What it used to be before is 0.5 meter a second, which is, I mean, it's interesting, but it's just not what I think would be a reasonable current in that domain. Okay, so I'm going to pop over to another window. And so here's the new way of doing things. What I'm going to do, so I'm loading the thing. So what I'm going to do is I have several things that begin with app. And you see app 1, app 2, and app 2 BS. The BS means Bootstrap. And I'll just run that. And this pops over here, and we can see how this works. So, right, so the changes that from before, the underlying code again is changing that water depth thing. The graphs are different, mainly there'll be red text at the top, which will tell you about the convergence. So what it's doing now in this new one, it's more accurate because it's doing an iterative approach. What do I mean by that? If the mooring is knocked over a fair bit, then this, for example, this instrument here, it has some height, I don't know, 0.5 meters or something like that. If it's, and I'm simulating only currents in the horizontal. And so that the area, if that thing is tilted by some, angle, which I'm trying to indicate by moving the mouse, then the sideways area component, projected sideways area, is less than it was before. So it does a first an estimate with the area being as though the thing were vertical, and then it's not vertical because it's been tilted out a little bit. It does another estimate. And the other thing is that here, this current in this simulation, the current is varying with respect to depth. So if that thing has been knocked down by whatever that is, 10, 20 meters, then the current is not what it originally was. Like, in other words, in the first iteration, for the float is using the velocity here. But after a while, this is after 6 iterations, we know that it's down here, so the velocity is less. Okay, so there are 2 factors for the iterations. One is the bending over, which changes the area of the elements, and the second, the bending over changes for depth-dependent velocity, changes the velocity that's experienced. The code has a criterion for this. It can do at most, I don't remember, 30, 40. It doesn't, you can find out easily, but it does some number of iterations for some tolerance. And this is a relative tolerance, so that if this water depth instead of 150 were 1,500 meters, then it would be trying for a tolerance of 1.1 meters. And that's changeable, not within the app. I don't have a control in the app, but it's really easy to change the code if that proved to be not satisfactory. I'm going to close this one. And I'll close this one. And I'm going to open the current. And for an example, I'm just going to change it now to a constant current. And as I click it, just look at maybe I'll say look at the left panel and just see how the shape changes. So it's knocked down a whole lot more. And the reason for that is that the current is a whole lot more. Previous, the current was only 0.5 meter a second at the surface. Now it's like that all the way down to the bottom. And I think that's basically what I wanted to show you there. What else? Maybe I'll close that. Obviously, we have the same sort of things that you can plot. And so I won't bother with that anymore. Okay, and I'm not clear that I want the names of these to be as shown, but like preset seems like a stupid name. But if you click on code, you'll see the code that could create this. And pretty simple. If you wanted to put in, this can only do one instrument. If you wanted to put more, just, and there's a thing called clamped. So just do question mark clamped to find out what that means. You just do clamped and then wire, then clamp something else and wire, and pretty simple, just like in the practical example. What else could I maybe show you? I'll just dismiss that guy. So this is a nearshore example, and you'll see the water depth will be now only 2 meters, and it only took 2 iterations to converge to nothing. I mean, it's truncating at 1 millimeter. So it didn't take much time at all to do that. That's because I have a constant velocity, constant with respect to depth. And if I change the current model to, shall we say, linear, you'll see the number of iterations will increase. Not saying necessarily by a lot. Didn't, it's still 2 iterations. It's also quite slow, and I'm not exactly sure why it's so slow. I'll be looking into the details I don't think it's because I changed the object orientation, but it might be. I'm not going to change it back because from my point of view, waiting 2 or 3 seconds is completely tolerable if it makes the underlying code more maintainable, such that users could maintain it. That's what I mean by that. Right, so that's the main difference. And again, if you're coding, which I think you really should be doing, you will have been using a thing you would have said anchor such model, comma, depth. If you try that now, it'll give you an error message because that's not how you're meant to do it. You're supposed to give the water depth down here as an argument now called water depth. It has to be the last parameter to this mooring call. Apart from that, everything is the same. Right, thanks for watching. So this has been just a kind of a little explainer on the changes to the app, to the package, the mooring package, and in particular to the app. And it's now called App2BS. Thanks for watching. Bye.